I'm really thankful to be speaking to you today about a topic that's near and dear to my heart, which is science for a sustainable blue economy. Before I start, I'd like to recognise the traditional owners of the lands that we meet on, their elders, past, present, and emerging. The knowledge they have about that land, and particularly about the oceans around it, is super important for the future. 97% of the water that we have on the globe sits in the oceans. The oceans produce between 50 and 80% of all the oxygen, and 75% of all animals still live in the oceans. You can see they're fundamental to our future. Now, for many of us, when we talk about the oceans and how humans interact with the oceans, they think primarily of fisheries and whether there's been a big discussion about whether those fisheries are sustainable or not. But the story is much, much bigger than that. There's now a large number of ways in which humans interact with the oceans, and it's getting to be a really busy place. These are all real photos of different parts of the ocean around the world. Now, if we compare what's happened on land in the last 50,000 or so years to what's happened in the ocean, we're a bit slower getting started in the ocean, but pretty much everything that happens on the land is now happening in the ocean. From fishing and shipping and tourism to building floating offshore islands for people to live on. All of the different ways that we use the oceans, those different industries, that's called the blue economy. Now, that blue economy is worth 70 trillion US dollars per year. That's a lot of money, and to put it into context, if you added that up and made it one nation, it'd be the 7th largest economy on the planet. And you can see from all of these curves that have the different ways that we use the ocean that they're all going up. They're all growing rapidly and doubling about every 10 years. And that doubling is expected to continue as we go forward. So to do that in a way that doesn't negatively affect the oceans, doesn't degrade the oceans, doesn't fill them up with pollution, all those kind of things, we need to find a sustainable way and an equitable way of doing it so we can all share in the benefits together. If we look at Australia in particular, around Australia, the waters around Australia, that's the exclusive economic zone, and that goes out to 200 nautical miles. That area is larger than our land mass. It has some of the best energy resources on the planet and lots of other things in there, fish, minerals, lots of things that could be really beneficial to Australia's future. Right now, all of the industries acting in that ocean area are worth $40 billion per year, and it's growing really fast, just like it is everywhere else on the planet. Two key parts of that blue economy are sustainable seafood. Australia already has a really great reputation for being sustainable, for having fresh, really great seafood. But we also have huge potential around low carbon energy, so renewable energy coming from the oceans. In terms of marine industries that can happen in Australia, the inshore area is getting really crowded. We already do lots of things along the coastline. There's already a lot of competition for space there. So we need to be, if we're going to expand, we'll need to operate in more remote and exposed and high energy areas. And that's not an easy thing to do. So we need to develop sustainable but profitable and equitable solutions. So things that are really going to work for us without affecting the environment. And that's such a big vision that 45 different groups, so industries and research organisations from 11 different countries, have come together as a part of a cooperative research centre. So this is bringing together industries for energy production, for food production, aquaculture, engineering, all of the different research groups, including the CSIRO and a bunch of universities, as well as government bodies, so that they can all work together over the next decade to find some solutions that give the blue economy of Australia and New Zealand a really great foundation. That's a really big body of work, and to make it a little bit more tractable, it's kind of grouped into 5 different parts. We work really closely together, but you can see here that we largely have 5 different research programs. The first of those looks at the engineering of how do you build things that can actually survive offshore and not get wrecked, basically. How can you build things that are robust, but actually leave space for the animals of that water to grow in it and around it, so that they can have a home without breaching the thing that you're trying to do. So without compromising the energy generation or compromising the farming. Also, how to do it safely. How do we use robots to go and clean the pens and check on how the growth is going of the fish? How do we have sensors that can glide around and check the conditions and report back to us so that we know what's going on? The second body of research is around knowing what animals to grow, particularly animals that can grow together. So if we take the idea of a food web or an ecosystem where different parts support each other and have different roles, can we do that in a farming sense so that it effectively cleans up and looks after itself so we get the benefits of their food production with a minimum of footprint? The next step is to look at renewable energy. So that's a quite large body of research in itself. So how do we generate the energy offshore? Then how do we store and transport it, for instance, with hydrogen? That's going to be really important because, as you can see from the map, at least half of Australia has really high energy potential. In fact, pretty much all of Australia has really high energy potential. We just need to know how to do it in a way that is safe and secure and can be brought back to shore in a useful form. Or it could actually be used offshore to support aquaculture and other things. These can be brand new centres of their own right. There's another whole body of research around the policy side. So how do you make the rules and regulations to make this fair and safe? What kind of economic structure, what kind of marketing is needed to be able to do all this? But also a really key part is how do we educate, how do we grow the future leaders, the future research scientists, the future industry around this blue economy idea? And how do we do that so that that fundamental idea of being sustainable, which is at the heart of the blue economy, goes through all of those different chains? Then we get to the bit that I help lead. So this is about environment and ecosystems. As I said, all of the different parts, all those different research bodies, each have their own focus, but they also link together. And that's one of our roles, to synthesize it all together, to look at how the environment responds to all of that production and the infrastructure and the building the pens, and how does it interact with it? Do animals run into things? Do they not like things? Do they cause damage? Can they happily live around it and as a part of it? So how do we find places that are safe and secure but highly productive? So where should we put this energy generation? Where should we put the farms? How do we monitor them to make sure that they're doing okay? How do we get all of that information and feed it back to people that have to make decisions about what to farm, where to farm, how well it's going, is damage being done, all of those kind of things. And ultimately, how do we figure out whether it's better to do it offshore than to find some way of doing it on land? All of those big topic areas are what the part of the research that I help lead has to figure out over the next 10 years. So how did I get to this point? Well, I started up growing up on a farm, a sheep farm, and my parents would take me to the beach a couple of times a year to try and get away for a holiday. When I was a teenager, I snuck out and I was sitting on the beach and a pod of dolphins came in and started swimming with me, and I got really hooked. So I'd always loved to know things. I'd always kind of been destined to be a scientist, but I thought I'd be a vet, as did my parents. Everyone was encouraging me to be a vet. But when I sat down and thought about what it would be like to be a vet versus getting to swim with dolphins and fish and think about the ocean all the time, I kind of went with the fish. First of all, though, I had to get the money. So I did get a scholarship, but also worked in the big merino to be able to, I made a lot of sandwiches basically, so that I could get the money together to go to university. I was lucky enough to go to university at James Cook, which is up in far north Queensland. It's quite near the Great Barrier Reef. I spent a lot of time literally on that set of chairs there outside the library doing all my university work in maths and marine biology. So I combined the maths as the language that I use to describe the marine biology to create computer programs of how the oceans work. From there, I went to Hobart, which is where I still live and work, and this is the CSIRO offices in Hobart. So despite having a love of being in the ocean, I actually get most of my science done inside a computer. So I sit in front of a computer, working up the different parts of all the science, bringing it together using maths as the language so that we can create versions of the ocean inside computers and play those forward. So under different kinds of fishing and different kinds of climate. It's a beautiful place to work. We get visitors from some of the more interesting parts of the marine system swimming past. It can be quite exciting. So bringing all of that information together, we can effectively make science-based computer games so that we can play out what the climate looks like. How does it affect the ocean? If humans start to build things like blue economy infrastructure, what does that do to the ocean? How do animals interact with it? How do they make it a house? Can they spread disease? Does it make the place a better place? Can we do it profitably and sustainably and safely? Because as I said before, being sustainable and equitable is at the heart of the blue economy idea. So we really want to do that well. That experience, that science career has allowed me to visit very many countries around the world and to work with people in all of those different countries. It's a really exciting and fulfilling kind of life. It's let me see things I could have never imagined before, like swimming with whale sharks and talking with indigenous elders sitting on beaches from Patagonia to Borneo. It's been a really, really exciting life. I've got to work with an enormous number of people. I've written scientific papers with over 500 different people from 79 disciplines. That's because science itself is so rich. There's so many options in science about what you can think about, what you can do. But actually, science is beyond just academic learning. It's connecting with people that have a deep knowledge of how the system works. That means working with people beyond science to find solutions. And that's been a really wonderful way of linking science with finding a sustainable future. Now, why do I do science? I do it for the thrill. I can't put into words the joy it is to find a new scientific facts. It's my happy place. It's kind of all of the expressions here that I could find. It's the joy, it's the wonder, and it's that focus that you can get where the whole rest of the world shuts out and you're just concentrating on that one thing. It's such a delightful way to, it's not so much a job, it's a way of life, so to speak. The other reason I do it is to help. I just like to know things, I like to understand things, I like to provide information so that we can see what the new options are. So part of that is understanding how the natural world works, and part of it is trying to find new technologies and new ways of thinking to progress us forward. And we live at a time that's super exciting in terms of the amount of technological power we have at our fingertips. I'm pretty sure that pretty much everybody who's listening to this talk has a mobile phone in their pocket or their bag or somewhere nearby. And those mobile phones individually, every single one of those phones has more power in it than all of the computing power that was on the planet when I did my PhD 20 years ago. We live in a time that we can access information in a way we could never have imagined before. At all different scales. We're starting to have things like eDNA sniffers where they can sniff water and know what animals went past. They can tell what bacteria is there and how it's growing and what it's doing in the water and what that means about the health of the water. They have robot sailboats that can drive across a whole ocean collecting information as they go. We can see from satellites everything around the planet. It's a really, really exciting time to be alive. The power in our watches is more than got us to the moon. So technology is a great way of bringing it back together, but we also need to connect with each other and talk through those ideas. Humans are still really critical to the ideas of science and bringing that sustainability and the blue economy to life so that we can live in solution with nature. And that's part of the role that I like to do, to have that help. Because a big part of doing science is to help people see things that they might have missed some other ways. To take that step back, to have that big picture view as well and see if they're missing something critical. So the future is blue. We are moving more and more into the ocean. It's going to be really important for climate and food solutions. Renewable energy will help on the climate front. Food security, the most effective way of getting protein is actually to get it from aquatic foods. They're really nutritious. They come in their own neat little package. They have the lowest carbon footprint of getting any kind of protein. They're a great food solution. So the blue economy is a hopeful future. It's a sustainable future and one that we can live together. And it's one that's evidence-based. It's really knowledge-based. It's also really fun, and it's a really great curious future that can be helped along by a lot of denizens, including fish. They're some of the most curious animals on the planet coming up and having a look at you. So it's a really great future to be a part of. I'd just really like to thank you for this opportunity to talk to you today.